This is the Earth Science Classroom. Welcome back to the channel. This video is all about contour lines, how to draw them, how to use elevations and points on a map to draw accurately contour lines. So let's do it. So I have a grid that I've drawn of showing elevations on a pretend Earth surface ranging from 30 up to 80, and this could be either in feet or meters, as in the unit of measurement. Now, elevation is how high the Earth's surface is above sea level, and we can draw a contour line, which is the equal elevation on the Earth's surface, going either direction, north, south, east, or west, and we can see where the elevation changes on the Earth's surface. So to start with, to draw a contour line, I'm going to have to connect the same elevation point to a same elevation point. So basically it's like connect the dots, like you did as a kid. And I've started with the elevation 50, generally 50 feet. And as you can see, I'm just putting a nice pencil line between the 50 points on the grid. And you can see that there's a connected line with no breaks. And across the whole grid, I'm connecting all of the elevations with the elevation 50. Now, in general, there's no real straight lines in contour lines in nature, but just for the demonstration purpose, I'm doing a kind of a straight line direct from point to point. So anywhere along that line is elevation 50. Now I can start with the 60 elevation. Again, I'm doing more of a smooth connection with less straight lines, just using the pencil to connect the dots. And again, it flows off the grid, and you assume that it's going to connect with obviously the 70 or 60 feet elevation. So again, I'm just drawing these contour lines, connecting the dots between the equal elevations from 50 to 60, 70, and now 80. Now we can see just from the numbers that they're increasing in elevation, in height. So the number's increasing, so we know that there's a hill, and then obviously on this side, the top right, it's going to reduce and decrease in elevation, and 70 and 60 in the top right. And again, to the left-hand side of the grid, we can't tell direction yet. We haven't got a compass there, but the left side, we have a smaller elevation area of 30 and 40 feet, so we can see where the areas are high. There's a high point or a ridge or a crest or a mountain on this map, this topographic map created by a bunch of contour lines, and we can see where the low elevation areas, the troughs or the valleys or the gorges could be. Now I did a little mistake there on purpose, so I missed out a elevation 30, so you got to make sure that you cover and connect all of the same elevations. You can't leave them out. So again, it may make the terrain different, but the contour lines are showing you the shape and relief of the landscape in a two-dimensional picture. So you're seeing it in 3D. You're going to picture it in 3D in your mind, but it's on a 2D piece of paper. So in real life, you're going to have different elevations across the landscape. You're not going to have perfectly whole numbers of 50, 60, 70 on the Earth's surface. You could have any elevation of whole numbers, no decimal points. So an elevation of 54 or 61. So I've drawn this grid to represent that, where there are these random numbers, and I still have to draw my contour line using whole numbers like 50, 60, 70. And 80. So I can find in the grid where those elevations are, even though they're not on the actual points and they're not listed. You can still find them in between, because in terms of numbers, to say 50 is going to be between 49 and 56 in the top left corner. So if I'm going to find contour line 50, I got to find along this straight line, 50 lies between 56 and 49, so about there. So I can start my contour line going through elevation 50. So even though it's not numbered on the grid, I can still find where 50 is going to be on the landscape, on the difference between the low number and the high number. So I'm connecting 50. As you can see, I'm figuring out where 50 is on each of the straight lines in between the elevations listed on the map, and I'm going to put my nice contour line going through elevation 50. Again, you've got to figure out where it goes, because it can't go higher than 50 or lower than 50. So you've got to figure it out. Again, once you've drawn the contour line, you can then label it. So now I'm doing 60. Now I'm going to figure out on each straight line where 60 is going to go. And I have to put it in the right place. I can't go too low or too high. I must put it on number 60. So I'm looking to see where 60 is going to fit in between the numbers shown. And then I can connect the dots as per previously done on that basic grid. And I can start to draw through. Now again, there's 60 right there. Go straight through that point and come down and around to, again, where 60 is, and where 60 is positioned, I can connect the dots, again making a nice continuous unbroken contour line with no straight lines. And the rule of thumb, these contour lines cannot overlap or cross or intersect, because you cannot have the same kind of two elevations for one point on the Earth's surface. Again, this is elevation 70, the contour line 70. So again, anywhere along this line, I am telling the world that anywhere along this contour line is elevation 70. Even though it's not listed on every point, I know that this line represents 70 feet on this imaginary Earth surface on the grid. And again, just finishing up with elevation 80, the contour line for 80. Again, figuring out where 80 is in relation to the numbers, and I'll connect the dots, and complete the contour line. So it doesn't really matter how close the contour lines are to each other, they just cannot touch or cross. So they're close together, that would mean something. If they're far away, that would also mean something. So in terms of the gradient, how steep a landscape is. I have videos on that if you want to check them out in the playlist on what the gradient is and what these lines represent. But there we go. We have 4 contour lines drawn on the map. So now we can get an idea of the three-dimensional shape on this map.